Hi everyone. In this session, we are going to discuss one of the most important topic for your NEET, JEE, IIT competitive examination. That's nothing but molecular orbital theory, MOT, molecular orbital theory. This theory, mostly they will ask you around 4 type of questions. Let's see what are the applications of MO theory. All right. So we have the applications of MO theory. Mainly we are using to find the bond order of a molecule. You know what is meant by bond order, right? Bond order, the number of bonds between two atoms, right? If you consider O2 molecule, oxygen, oxygen. You know what is a bond between two oxygen atoms, right? It's a double bond. So what is the bond order? 2. Number of bonds between two atoms is known as what? Bond order. If you consider hydrogen, H2, hydrogen, hydrogen. What is the bond between two hydrogen? One single bond. So what is the bond order? 1. And N2, between two nitrogen atom, you know, triple bond. Bond order is 3. Suppose I'm asking you, in the molecule N2 plus, what is the bond order? O2 minus, what is the bond order? It's not exactly what? 2, 3 like that. Okay. So we can discuss what is the bond order of a molecule. You can calculate through the principle MO theory. Second one is called the molecule is paramagnetic or diamagnetic. That also we can say. And stability of a molecule, you can explain even the existence of a molecule. You know, H2 molecule existing, right? N2 molecule existing, right? What about Be2, He2? We can discuss. So first we are going to discuss about the bond order calculation. You have to study only 2 equations. One is enough. If you know the first equation, that is up to 14 electron system, you can able to answer all these datas. Bond order, paramagnetic or diamagnetic, what is the stability, what is the molecule can exist or not. Everything you can explain through just one single equation. So first we are discussing a pure theory about the MO theory, molecular orbital theory. After that we can go for the short trick. So first question, up to 14 electron system, what is the order? What is the arrangement of molecular orbital? Dear student, you know very well how the molecular orbitals are forming, right? You know, atoms are combining together, you are getting molecule. Similarly, atomic orbitals, you know, s orbital, p orbital, those kind of atom containing orbitals are mixing together, we are getting the compound, which one? Molecular orbitals. Alright, so atomic orbitals combine, we will get molecular orbital. You know how to write the electronic configuration, right? You know, for example, you will write 1s2, 2s2, 2p6, 3s2, like that, right? That is atomic electronic configuration. For an atom, for a molecular orbital, what is the arrangement of molecular orbital? That one writing up to 14 electron system, what is the rule? Just to study only this one, dear all of you. One is called sigma 1s, sigma star 1s. So what is this? Without star, one is we are writing without star, one is with a star, right? The without star, that is known as BMO, you know, bonding molecular orbital. Without star, that is known as BMO, bonding molecular orbital. With a star, that is called ABMO, anti-bonding molecular orbital. BMO stands for bonding molecular orbital. ABMO stands for anti-bonding molecular orbital. Alright. So study this order all of you. Sigma 1s, sigma star 1s. Why we are writing the symbol less than? This is the, each of them are molecular orbital. Okay. Sigma 1s is one of the molecular orbital. Sigma star 1 is the other molecular orbital. We are writing in the increasing order of energy. So sigma 1s, sigma star 1s. We have sigma 2s, sigma star 2s. After that, we are writing a special one. You know, pi 2px is equal to pi 2py. Why they are writing equal? Why they are writing equal? Because they're having equal energy. They're having equal energy. All right. So, you know, those orbitals having equal energy are known as what? Or is known as what? That is called degenerate orbital. Those orbital having same energy are called degenerate orbitals. Okay. Now, so after pi 2px equal to pi 2py, we can go with another one, sigma 2pz. Sigma 2pz. So once again rewind. Once again, rewind. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px equal to pi 2py, then sigma 2pz. For every BMO, there will be a ABMO. Alright, for every BMO, there will be a ABMO. So this is sigma 1s, it's ABMO. Sigma 2s, it's ABMO. This pi 2px, pi 2py, these are BMO, right? Without star. Sigma 2pz also without star. They are BMO. So their BMO, there will be a corresponding ABMO. What is the next one, dear all of you? Pi star 2px equal to pi star 2py, and the last one is sigma star 2pz. If you know this order regarding molecular orbital theory up to 14 electron system, you can able to answer all those questions. Okay. So these are BMO. So can you identify which all are BMO and ABMO in the system? This is BMO. You know, BMO means without star. ABMO means with a star. Okay. So this is BMO, 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 BMO. Okay, and remaining all are with a star. They are all are ABMO. This is ABMO, 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 and ABMO. So up to 14 electron system. What is up to 14 electron system? For example, you can consider one of the example like N2 molecule. You know, one nitrogen atom contains 7 electrons. So 2 nitrogen means one nitrogen molecule contains 14 electrons, right? 14 electrons. So these kind of system, you can apply this equation. Another one. For example, you are considering B2 molecule. What is the number of atoms in boron? 5. So B2 molecule 10. So you can apply up to 14 electron system, including 14 electron system, you can apply this equation. Then what about more than 14 electron system? For example, you know, dear all of you, O2 molecule, one oxygen contain 8 electron. So O2 molecule contain 16 electron. Right, 16 electron. This is more than 14, right? More than 14. So what we have to do there? We have to apply one another equation. For more than 14 electron system, we have another equation. Simple one. If you know up to 14 electron, this is so easy. I'm making the first equation into different sets, okay? 1, 2, 3, 4, 5, 6, 7, 8. Okay, total 8 set. Among that, the 5th one and the 6th one, you just interchange. You will get the equation for more than 14 electron system. Which mean first 4 are equal. Just copy here. This 6th one, make it 5, 5th one, 6th one. Alright. Then this one, same repeat. So let me write once again. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Then what we have to do, dear student? Make it this here, sigma 2pz here, and we have pi star 2px equal to pi star 2py, and the same one. Okay, that's it. So first of all, I didn't make any change. I just copy here. The 5th one and 6th one just interchanged, and 7th and 8th exactly like that. That's it. Now we can go for the questions. Okay, so just to study up to 14 electron system, then just arrange the 5th and 6th, just rearrange it. You will get more than 14 electron system. What is the equation? Now we can see what is the application of these molecular orbitals. One more thing. In each molecular orbital, you can fill maximum 2 electron. Once again, in each molecular orbital, you can fill maximum 2 electron. Alright, so let's go. First, we are discussing about how to calculate the bond order of a molecule. Once again, what is meant by bond order? Number of bonds between two atoms. Alright, number of bonds between two atoms in a molecule. First example, we can go with N2. Now I'm saying about the real calculation of bond order. After discussing 1 or 2 sample, we can go for the short trick. Within second, you can able to answer what is the bond order of a molecule. So here N2, alright, N2. In N2 molecule, how many electrons are there? In N2 molecule total, there are 14 electrons, right? Alright, N2 molecule which contain 14 electrons. So which equation we have to apply? The first equation or the second equation? First or second? Up to 14, right? So we can apply the first equation. All right. So let me write the orbital once again. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. What we have? Pi 2px equal to pi 2py. Then we have sigma 2pz. Then pi star 2px equal to pi star 2py. And last one, sigma star 2pz. All right. Let's fill 14 electrons. Okay. 14 electrons. I told you that in each molecular orbital maximum you can fill 2 electrons. So we can fill 2 plus 2, 4, 6, 8. Dear all of you, when you are filling energy in the degenerate orbital, which means equal means same energy. In those orbital, when you are filling electron, very careful. You have to follow the Hund's rule. You have to follow the Hund's rule. What is Hund's rule? After single occupation of electron, only pairing can happen. Okay, these are single molecular orbital, right? But these orbitals having pi 2px and pi 2py, pi star 2px and pi star 2py. These having same energy. In those orbital, when you filling energy, very careful, after single occupation of electron, then only pairing can happen. Which means 2, 2, 2, 2, here 1, 1. Okay, singly occupied, then pairing 2, 2. Okay, so 2, 4, 6, 8, 10, 12 over. Here we can fill remaining 2 more electrons. So 14 electron we filled. Okay, 14 electron we filled. So this is about the arrangement of molecular orbital and the distribution of electron in each molecular orbital of the molecule N2. Now we have to calculate bond order. We have a short equation, but that's not required actually. Okay, we have a short trick. The real equation to calculate bond order is equal to the equation half of NB minus NA. This is the equation. What is meant by NB? What is NA? Let's see. NB means that is the number of electrons. Okay, NB means the number of electrons in BMO. What is BMO? Bonding molecular orbital. So what is meant by NA? Represent number of electrons in ABMO. What is BMO? That without star, right? ABMO with a star. So in BMO orbital, how many electrons are there? That is called NB. In ABMO orbital, how many electrons are there? That is called NA. Let's count. So half of, tell me dear. Can you please count what is the number of electrons in BMO? Which all are BMO? Okay, 1. So there's one of the BMO 2 electron, 4 electron, then 6, 10, 6, 8, 10. Right. Total 10 electrons are there in BMO. Total it is a 14 electron system. Already 10 electrons in BMO. Then where is the remaining 2 electron? In ABMO. Right. Where is that? This one and this one. So total 4 are there. So 10 minus 4, 6. 6 by 2 is equal to 3. You know very well, between 2 nitrogen atom, how many bonds are there? 3 bonds are there. Yes, 3. That is the bond order calculation. Let's go to another question. For the molecule O2 is a 16 electron system, dear all, right? 16 electron. We have to apply the second equation. What is the second equation? Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Do you remember? Fifth one and sixth one we interchange, right? What was that? Sigma 2pz here. Then pi 2px equal to pi 2py. Then we have pi star 2px equal to pi star 2py. Last one is sigma star 2pz. Alright. Let's go and fill the total 16 electron system. Let's fill, dear all of you. 2, 4, 6, 8, 10. But this is a degenerate orbital. What is the criteria? After single occupation of electron only, pairing can happen. So 10 electron over 11, 12, 13, 14. Alright. 15, 16. Because this is also degenerate orbital. Alright. Yeah. Now we can go for the calculation. Bond order is equal to half of NB minus NA. Alright. So we can write half of What is the number of electrons in BMO? All of you count it. 2, 4, 6, 8, 10. Alright, 10 again. What is the number of electrons in ABMO? Total it is a 16 electron system. So remaining 6 electrons will be in ABMO. What is that? 2, 4, see 5, 6 electron. So 10 minus 6, 4, 4 by 2 is equal to 2. Yes, we know very well between two oxygen atoms there are 2 bonds. So bond order is equal to 2. Correct? What about N2 plus? Dear student, N2. You know, nitrogen molecule total contain 14 electron, but what about N2 plus? How the element getting or a molecule getting positive charge by losing 1 electron? Right? Here plus 1. What is the charge? N2 plus 1, right? Plus means it lose 1 electron. If it is plus 2, lose 2 electron. If it is minus 1, gain 1 electron. If it is minus 2, gain 2 electron. Okay, so N2 molecule containing 14 electron, but N2 plus contain how many electron, dear all of you? It will lose 1 electron, so it contain remaining 13 electron. So 13 electron system also we can use the first equation, right? Up to 14 electron we can use the first equation. What is the first equation once again? Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Then we have up to 14. Alright, so we have pi 2px equal to pi 2py, then sigma 2pz, then we have pi star 2px equal to pi star 2py, and last one, which one? Sigma star 2pz. Alright, so we can arrange the electrons. Okay, we can 13 electron. So 2, 4, 6, 8, 9, 10, 11, 12, 2, 4, 6, 8, 10, 12, 13. Okay, filling of electron over. Let's go to the calculation of bond order. Bond order is equal to half of, what is the number of electrons in BMO? 2, 4, 6, 8, 9. 9 minus, here 2 plus 2, 4. So that's equal to 5 by 2, that's equal to 2.5. So you may think if the bond order can be a fraction value, a decimal value, 2.5, 1.5 like that. Yeah, what's that meaning? You know, bond order 2 means double bond. Bond order 3 means triple bond. So what is the meaning of bond order 2.5? The strength of the bond between the double bond and triple bond. The strength of the bond between a double and triple bond. Alright, so that's the meaning one. So what is the bond order in nitrogen? N2 plus 2.5. Now we are going to the short trick. You know, during NEET and JEE IIT examination, we don't have enough time to practice all the sigma 1s, sigma star 1s. It will take a lot of time. Let's go a small short trick idea. You can able to answer all the questions from MOT. So let's go for that. Bond order calculation. What is the short trick? Listen all of you carefully. I'm going to arrange one of the system in which, you know, maximum we can fill up to 20 electrons in the molecular orbital. Just observe. If you are completely filling in all molecular orbital, what is the situation? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Right? Up to 20 electron we can apply this system. So I'm making a steps. All of you listen carefully. I'm starting from 8 electron system. Okay, 8 electron system. If a system contain 8 electron, let me write like this, 8. Okay, this is 8 electron system. 8, 9, 10, 11, 12, 13, 14. Up to 14 electron system, right? Up to 14 electron system, that's our data. Okay, after 14, let's go for 15, 16, 17, 18, 19 and 20. Okay, from where we started? 8, okay, 8 to 20. So let me write the number of electrons outside. Alright, I'm writing the number of electron left side. Okay, left side means outside of this system. 8, 9, 10, 11, 12, 13, 14, just write on the top, because up to 14, more than 14 system, no. So 14, you'd keep it the top. Then after 14, just write 15, 16, 17, 18, 19, up to 20. So you may think the question, sir, there are so many systems, right? Less than 8 electron, hydrogen, right? Be2. What about that? We can go with that. That's another system. So let me write the answer for these systems first of all. So what you have left side? Number of electrons. Okay, left side which I represented, all are number of electrons in the system. These are number of electron. 8 to 20 which I represented, number of electron in the system. Inside, I'm going to write the corresponding bond order. Without doing the calculation half of NB minus NA, we can directly go with that. So I'm just writing, all of you carefully listen, what is the bond order in each case. Very simple. If 8 number of electrons are there, bond order is 0. Okay, bond order is 0. Now you add 0.5 in each step. 0 plus 0.5, 0.5. 0.5 plus 0.5, 1. 1 plus 0.5, 1.5. Add 0.5, 2. Then here, 2.5. Here it is 3. Understood? Easy, right? So 8 electron system, bond order 0 in each successive step, just add 0.5. That's it. So up to 14 electron system, 3 is the bond order. We just observe now. In nitrogen molecule, how many electrons are there? 14 electron. What was the bond order in nitrogen? 3, right? Yes. Now you do one thing, the same bond order, you just copy here. Here 2.5, here 2.5. Here 2, 2. 1.5, 1.5. 1, 1. Here 0.5, 0.5. Here 0, 0. That's it. Easy? Then what about less than 8 electron system? Less than 8 electron. That another rule. Okay, another data. Less than 8 electron, what all I have? 7, 6, 5, 4, 3, 2, 1, 0. Alright, let me write the electron. 8, here 7, 6, 5, 4, 3, 2, 1, 0. Okay, let's begin. This is another rule, a small data you remember. 0 to 0.5, 1 to 0.5. What? 0, 0.5, 1, 0.5. 0, 0.5, 1, 0.5. Repeat 2 times. 0, 0.5, 1, 0.5. 0, 0.5, 1, 0.5. That's the order. Okay, 0, 0.5, 1, 0.5. One set. Again repeat. 0, 0.5, 1, 0.5. This is the way you can identify the bond order of a compound. Let's see the previous question what we did through the equation. Dear all of you, we did N2. N2 molecule, how many electron system? 14 electron system. All of you observe what is the bond order we calculated for 14 electron system? 3. Let's check it. Yes, right? 14 electron system, bond order is 3. Then, what is the bond order of O2 molecule? What is the number of electron in O2? 16 electron. For 16 electron, what we calculated the bond order? 2. Let us check it. Where is 16 electron? Where is 16 electron? Yes, 16 electron. What is the bond order? 2. Then, N2 plus how many electron we said? 13 electron. For 13 electron, what is the bond order? 2.5. Let's check it. Where is that? 13 electron. Yes, the bond order is 2.5. So by using this data, you can able to answer bond order so fast. No need to do the sigma oneness, all the molecular orbital and the full equation, not necessary. Okay, next question or the next application of which one? The molecular orbital theory. The first one, whether the compound is paramagnetic or diamagnetic. You can say about the magnetic property of a species, whether the paramagnetic or diamagnetic. What is the meaning of paramagnetic, dear all of you? Paramagnetic means the substance which contain some unpaired electron. Some number of unpaired electrons will be there. They contain paramagnetic compound mean they contain unpaired electron. Unpaired electrons. Unpaired electron in the sense just odd electron, single electron. If at least one electron, if it is there, it will be paramagnetic. As the number of unpaired electron increases, their paramagnetic character increases. Then what about diamagnetic? They having paired electron. Paired electron. We are seeing now, if you consider sigma 1s2 and sigma star 1s1. Here I am writing sigma 1s2 and here sigma star 1s2. Which is para, which is dia? Can you see here one unpaired electron? A single electron? Yes, therefore it is paramagnetic. Can you see here both are paired, right? They are called diamagnetic. That's it. So how can you identify from this one? By calculating bond order, we won't get the idea. You have to write the electronic configuration, molecular orbital. Let us check it, the previous questions, okay? Can you tell me, dear all of you, nitrogen molecule is paramagnetic or diamagnetic? Nitrogen molecule is para or dia? All of you please observe this one. Can you see anywhere a single electron? Here two, all are paired one. So it is diamagnetic. Nitrogen molecule is what? Diamagnetic, right? What about oxygen molecule? Just observe all of you. In the oxygen molecule, can you see anywhere a unpaired electron? Unpaired electron? Yes, right. These all are paired one, but the last two orbitals are unpaired. Just one electron enough to make it para. Okay, so here two electrons are there. It is highly paramagnetic. What about N2 plus molecule? In N2 plus molecule, can you see anywhere odd electron? Yes, the last electron is odd one. Therefore, this is also paramagnetic. So we can say that nitrogen molecule is which one? Nitrogen molecule is diamagnetic. Nitrogen molecule is diamagnetic in nature. Whereas O2, right? O2 molecule is paramagnetic in nature. O2 molecule is paramagnetic in nature. What about N2 plus? That's also paramagnetic in nature, right? They are also paramagnetic in nature. Okay, this way you can identify the magnetic property of a molecule. This is the second application of which one? Molecular orbital theory. Shall we go to the third one? All right. The third idea about molecular orbital theory, you can explain the stability of a molecule. Suppose I am giving you a set of molecule, dear all of you, just note it. The first set I am giving you O2, O2 plus, O2 minus, O2 2 plus. Okay, O2, O2 plus, O2 minus, O2 2 plus. I am asking you, what is the order of stability of this molecule? Easy, okay. This is the point all of you keep in mind. The bond order, if the bond order of a molecule increases, you know, the stability and the strength increases. What's the bond order? Bond order increases, the stability of the molecule increases. Why? You just think over it. What is the bond between hydrogen and hydrogen? You know, it's a single bond. What is the bond between two oxygen? You know, double bond. Between two nitrogen, triple bond, right? So what is the bond order here? 1. Bond order 2. Bond order 3. You know which bond is stronger? Triple bond is stronger, right? As the bond order increases, the strength and stability of the molecule increases. Okay. First of all, the O2. Can you tell me, dear all of you, O2 molecule, how many electrons are there? Yes, 16 electrons are there, right? 16 electron. What about O2 plus? O2 means 16 electron, plus mean it lose 1 electron. So it is having 15 electron, right? And what about O2 minus? O2 minus. O2 having 16 electron, minus indicate add 1 more electron. So you have total 17 electron. What about O2 plus? O2 plus, O2 contains 16 electron, 2 plus mean it lose 2 electron from that. So remaining 14 electron system. So O2 contains 16 electron, O2 plus contains 15, O2 minus 17, O2 2 plus 14 electron. Okay, now you know how to calculate the bond order, right? Can you please tell me? 16 electron. Dear students, 16, 15, 17, 14. Let us calculate the bond order. 16 electron system, where is that? 16 means bond order is 2. Okay, 16 means we can say bond order, just I am noting here all of you. For 16 electron system, bond order is 2. Okay, bond order is 2. Then 15 electron, what is the bond order? 15 electron 2.5. Okay, for 15 electron system, the bond order is 2.5. Here it is 2.5. Okay, what about 17 electron? For 17 electron system, where is 17 electron system? For 17 electron system, 1.5. Okay, for 17 electron system, the bond order is 1.5. What about 14 electron system? The 3 is the bond order. So 14 electron system, 3 is the bond order. Okay. So which one having greater bond order, their stability greater. So can you tell me which is more stable one? Greater one is for O2 plus. So we can say O2 2 plus is greater stable than, after that least one, O2 plus. After that, O2. And the least stable is which one with the least bond order? That is 1.5. That is our O2 minus system. Alright, so this is the way you can calculate. Same way, they can ask you some other question. For example, N2, N2 plus, N2 2 plus, N2 minus, etc. Same procedure. In N2 molecule, how many electrons are there, dear all of you? 14 electron. You can calculate the bond order from that. N2 plus mean how many electron? 13 electron. N2 2 plus 12 electron. And N2 minus 15 electron. Can you calculate the bond order? Can you say the stability order? Yes, that's it. Next one, the last main property of molecular orbital theory, you can explain the stability of and the existence of a molecule. Whether a molecule can exist or not, you can say about that. See, the thing is, first I am taking one of the example, He2, helium, okay, helium, it's a noble gas, helium-2. How many electrons are present in one helium? 2 electrons. So 2 helium, 4 electrons. So one helium molecule contain 4 electrons. Okay, so it is a 4 electron system. Let me just write the electronic configuration, okay, the molecular configuration. 4 electron, how can we write, dear all of you? Sigma 1s, sigma star 1s. This is enough, no? Okay, 2 electron here, 2 electron here. Okay, let me calculate for beryllium. Beryllium, hydrogen, helium, lithium, beryllium. Beryllium, the atom contain 4 electron, Be2 molecule contain 8 electron. Alright, 8 electron. So how can you write sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. That's enough. Let's fill 8 electron, 2, 4, 6, 8. Alright. Nitrogen molecule already 14 electron system. We can write sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, and pi 2px equal to pi 2py, and we have sigma 2pz. The others are there, not required. Up to 14 only, no? So let's fill 2, 4, 6, 8, 9, 10, 11, 12, 14. Alright. How can you say the existence of a molecule? The way is this one. If the bond order is 0, molecule cannot exist. What's the data? If the bond order is 0, molecule cannot exist, dear all of you. Molecule cannot exist, okay? Bond order 0 means molecule cannot exist. Why? What is the bond order between two hydrogen? Two hydrogens are connected through a single bond. So bond order is 1. Right? If oxygen, if you consider two oxygens are connected through double bond, bond order is 2. If bond order 0 means, what is meant by bond order? Number of bonds between two atoms. Bond order 0 mean there is no bonds here. So how the molecule can join? How the molecule can state in a, the atoms can combine together? No. Alright, so bond order 0, molecule cannot exist. Fine. Here, total, how many electron system here? 4 electron system. Okay, 4 electron system. Let's see the bond order. For a 4 electron system, where is 4? All of you, for the 4 electron system, bond order is what? 0. What about the other one? Let's see 8 electron. Okay, 8 electron. Let's see, where is 8 electron? Where is 8 electron? Yes, 8 electron system also bond order 0. Which all system having bond order 0? See, 4 electron system, 8 electron system, and then here 20 electron system. Especially these kind of cases, the bond order is what? 0 state. Okay. So what about last example we still discussed? Nitrogen. Nitrogen, what is the bond order? N2, 14 electron, 3 is the bond order. So we can say that which all molecule cannot exist? Which of the molecule cannot exist? Which one, dear all of you? Helium-2, Be2 cannot exist because their bond order equal to 0. Bond order is equal to 0. What about nitrogen? It can exist, right? It can exist because it having a bond order 3. So dear all of you, these are the major way you can able to answer all type of question from the chapter or the topic. Chapter is which one? Chemical bonding and molecular structure. The topic is MOT. So if you know up to 14 electron system and more than 14 electron system, those equation, you can able to answer all those type of question. So what are the major applications of molecular orbital theory? You can calculate the bond order. Okay. Bond order maximum follow this technique. You can calculate the bond order of any molecule up to 20 electron system, and you can calculate the molecule is paramagnetic or diamagnetic. The third principle, you can calculate the stability of a molecule, and the fourth one, you can say the existence of a molecule. Alright, dear all of student, hope you clear all the concept regarding the molecular orbital theory. So let's crack NEET and JEE examination through these simple tricks and tips. Let's see in the next video with some new concepts. Thank you all. Bye.